We all know the Earth contains lots of water. In fact, the majority of Earth's surface is covered in water. Of the water that exists on Earth, only 3% is fresh water, and the other 97% is found in oceans. Most of this fresh water is found in glaciers, 30% found in groundwater, and 1.2% found in surface waters such as lakes, dams, and rivers. Groundwater can be an important alternative source of water in cities, for sanitation systems, for farming, and for drinking water. This is particularly true in areas that don't have access to good quality surface water. South Africa is a water-scarce country that receives on average 500 millimeters of rainfall per year. This is a mere half of the world's average. 2/3 of South Africa's surface area is dependent on groundwater, including approximately 300 towns and settlements. So what exactly is groundwater? Well, below your feet, in the ground, water is contained in tiny gaps between the soil or in fractures in the rock. When it rains, water seeps through the soil and becomes part of the groundwater. This process is known as recharge. Understanding recharge is a good way of determining safe extraction limits from groundwater. As long as the long-term water inputs exceed the withdrawals, groundwater should be sustainable. This is where dating groundwater comes into play. If we can determine the age of groundwater, this will give us an idea about how quickly the aquifer recharges and ultimately help us manage groundwater resources. Dating can be done using isotopes. This method compares the amount of a naturally occurring radioisotope to its decay product. The amount of decay that has occurred can tell us how old the water is. Hang on a second, what's an isotope? Well, atoms in a chemical element that have a different number of neutrons to the number of protons and electrons are called isotopes. Some isotopes are naturally unstable. This means that over time, they decay into another element. Scientists are able to compare the concentration of the parent isotope to its decay product in order to see the amount of time that has passed. This works because we know the speed at which the radioactive decay takes place. So there you have it. Groundwater is a great alternative to surface water, particularly in arid areas. Groundwater research continues to be significant. We should have all the information we can in order to ensure the sustainable future of groundwater resources.